Welcome to the class, my dear students. In today's lecture, I'm going to explain you about the continuous probability distribution. What is a continuous random variable and what is the continuous probability distribution? In the previous lectures, we have done about the discrete random variable, what is meant by that, and what are the discrete probability distributions. Namely, we have done the Poisson and binomial. Now let us continue with the continuous random variable. What do you mean by the continuous random variable is whose values are uncountable or measurable. That means it may be the time, or it may be the percentage, or it may be the CGPA of whatever the grade you have got. Suppose the marks percentage, how much you have got. It is maybe 1.3, 3.3, like that you may get the grade, right? Or the weight or the height, everything. These are the variables which are the continuous random variables. So now in the discrete probability distributions, we have defined the probability mass function. Whereas when you define about the continuous probability distributions, then we define the probability density functions. That is what we have to understand. Now if you learn this by making the difference between what is continuous and under discrete, what are the criterion we have, then it will be easy for you to memorize. Now, in the discrete probability distribution, we have taken that the probability of x is greater than or equal to 0 always. So, here also the continuous probability distributions, your function f of x must be greater than or equal to 0. And in discrete case, we have considered that the sum of all the probabilities is equal to 1. Whereas here, because it is a continuous function, we are taking the integral of minus infinity to infinity f of x dx is equal to 1. And the definition for finding out the probability of x lies between a and b is given by integral a to b f of x dx. It's nothing but when you do in calculus, you would have learned what is meant by integral a to b f of x dx is nothing but the area under the curve f of x from x equal to a to b. So that will be the area, and that gives you the probability of the region between a to b. Now the mean of the continuous random variable is given by e of x and is given by integral minus infinity to infinity x into f of x dx. Whereas in discrete, it is sigma x into p of x we have done, which is the expected value of x. And now the variance is given by, in discrete case, it is sigma x square p of x minus the mean square, right? The same here also, it is integral minus infinity to infinity x square times of f of x dx minus the mean square. The mean is what? X f of x dx the whole square. So this is what the differences between discrete and continuous. Please don't get confused what was asked in the question, and you have to understand in the question by reading that whether it is a continuous random variable or it is a discrete random variable. So let us now start with some of the problems. Given that x is a continuous random variable with the probability density function, the mean is given by this and the variance is given by this, is what we have discussed just now. So let us now start the problem. The current measured in a thin copper wire in milliamperes has a range of 0 to 20, and it has a density function f of x is 0.05 and x lies between 0 and 20. Okay. So now coming to the point here, what is the function f of x is 0.05. And what is this function explaining about which variable? Your x is a variable which is the current measured in a thin copper wire. So it is very clear that current is measured means it is a continuous random variable. So now f of x is 0.05 is the function given, and x lies between 0 and 20. So he has asked you in this question that the current measurement is less than 10 milliamperes. Suppose, what is that probability? So probability of x less than 10, integral of minus infinity to 10, because what is the definition of probability of x less than x is given by integral of minus infinity to infinity f of x dx. This is what the function. So now when you write this as p of x less than 10, it is from minus infinity to infinity, but In minus infinity to infinity, the function is defined? No, right? It is from 0 to, where for 0 to 20 only the function is defined. But we need only from 0 to 10. This you can understand in this way. Just by drawing the real line, you will make it understand that the function is defined between 0 and 20. Then only the function has been defined, and the function value is 0.05. Now he has asked you in this question, 0 to 20 is defined, but you need to find out only for x less than 10. So in this region, whatever the function has been defined, of course the same 0.05 only, then what is the probability that for less than 10? So integral 0 to 10 is the limit 0.05 dx. Okay, now it's a normal integration, 0.05, take it out, integral dx is x, limits, put the limits, upper limit minus lower limit, which gives you the value 0.5. Okay, now let's go to the second question to find out the mean and variance. What is the mean here? 0 to 20. What is the formula? The whole mean from 0 to 20, the function is being defined. So x times of f of x dx, that is x times of 0.05 dx. Now normal integration, integral x